NAT, network address translation, NATing. Why do we need NAT? You see, our network will be using private addresses. So if you take any organization, within the organization you may have many routers, many computers. There may be many routers, many networks, and then many computers. At last, to go online, we will be connecting to an internet. We'll be connecting to internet. Yeah. So we got the internet, which is only public network. And inside our organization is private. You got a private network and you got a public internet. You see, 10001 that you use in your organization is also available. It is also used in your neighbor's organization. You need to understand that very well. Private address is seen as a duplicate, meaning it is seen in various other companies, friends, network. So he is also having 10001, you're also having 10001. Because it is private, we are free to use any private address within an organization. So if there is an Yahoo server, I'll write 80.001. If this B access Yahoo, if the address is 10001, then Yahoo will not know to whom to forward, whether to forward to this 10001 or this 100. Confusion, you see. That's why the private addresses are not allowed to be used in public. So what they do is they give you a public IP address, let's say 1001. Here they have given 2222. 11111 2222. Yeah, so this is public IP address. Every organization is given one or two or three public IP addresses, so that all these computers here, when they want to communicate within the organization, they use their private addresses like 10.001, 172.16.0.1. These are all private. They use their private addresses to communicate. But when they try to go outside, whether A is trying to go outside or T is going outside, the address of A and T will be translated to this public IP address. So when Yahoo receives packet from A is asking for Yahoo, and the packet is going to Yahoo. When Yahoo receives the packet, the source address will not be 10.001. The source address of the packet will be 1.1.1.1. Now Yahoo can easily reply to 1.1.1.1, and this will be translated back to 10.001. This is what called as NATing. What is NATing? translating from an inside local address to inside global address. That's too technical, right? Let me put it in a simple way. Translation from a private IP address to a public IP address so that your packet can go to the public network and communicate with the public network, and public network will be able to reply back to the NATed address, and the reverse NAT can happen. So let me repeat again. When you request Yahoo from A, when the packet is received here, the source address of the packet is 10.0.0.1. What this router edge will do, edge router, what this will do, it will take out this 10.0.0.1 and it will put 1.1.1.1. It will map it with different address. So when the same packet goes out, it goes out as 1.1.1.1. And Yahoo is going to now respond to 1.1.1.1. When the reply comes to 1.1.1.1, it will be remapped, it will be retranslated. Reverse natting, this is what called as reverse nat. It will be reverse nat and the packet will be forwarded to 10.0.0.1, and that's how the packet comes here. Likewise, when 172.16.0.1 asks for Google, 172.16.0.1 will be translated to 11111, and Google will respond to 11111. It will be re-natted to, reverse natted to 172.16.0.1, and the reply comes. If you don't do this address translation, the communication will not happen between the private and the public. Right? So, natting makes today's private networks to communicate to public internet. If no natting, then all need to be in public if you want to go to internet, which is not possible because our IP address is only 32-bit size. Natting makes the devices in private network to communicate to public as they are going to be translated to a public address as they leave the organization to meet the public network. Do you have a question on what is natting?
No, sir.